On May 1st, 2024, an apparently ordinary event began to form on the surface of the Sun. A new sunspot appeared on its eastern edge. At first, it seemed like just another one among many that regularly appear and disappear. However, as the days passed, this sunspot grew impressively, reaching a colossal size, 17 times the size of Earth. Scientists classified it as Active Region 3000, and it soon became clear that it would live up to its name. This gigantic sunspot began releasing intense bursts of radiation, known as solar flares. Some were so powerful that they caused coronal mass ejections directed toward Earth. The result was one of the most spectacular displays of auroras ever recorded, with colorful lights illuminating the skies in regions where such a phenomenon is extremely rare. According to NASA, this was the most intense geomagnetic storm of the last 500 years, so powerful that it even affected structural observatories. And the Sun didn't stop there. After the May surge, it continued emitting M-class and X-class flares at lower intensity, keeping space weather experts on high alert. But then, on October 3rd, something even more impressive occurred. A massive X9.0 class solar flare, the most intense in the last 7 years, was released directly from the center of the solar disk. Just 1 week later, a powerful G4-level geomagnetic storm hit Earth, triggering spectacular auroras and interfering with radio communications in various parts of the world. All of this pointed to one thing: the solar maximum was approaching. Now, NASA has officially confirmed it. The Sun's magnetic field has flipped, and we have entered the period of maximum activity in the solar cycle. But what exactly does this mean for our planet? How long will this intense phase of the solar cycle last? And most importantly, could this increase in solar activity raise Earth's average temperature in the coming months? The Sun may seem like a constant and unchanging source of light, but in reality, it undergoes cyclical changes that influence our planet in many ways. Approximately every 11 years, it goes through a transformation process known as the solar cycle. This cycle affects its activity, magnetism, and even its appearance. The discovery of this pattern dates back to the late 17th century, when astronomers identified a peculiar pattern in sunspots, dark regions on the surface of the Sun. Over time, they realized that these spots followed a cycle, increasing and decreasing in number every 11 years. This behavior became known as the solar cycle. With advances in technology, scientists began to observe not only the number of sunspots, but also other variations that occur throughout the cycle. One of them is the Sun's magnetic field, which completely reverses with each solar cycle, marking the midpoint of the cycle. In addition, solar activity, including solar winds, flares, and coronal mass ejections, also increases. After all, the Sun is an immense sphere of electrically charged plasma, and its magnetic field is constantly changing. Since the discovery of solar cycles, scientists have been monitoring these patterns, numbering each cycle. We are currently in solar cycle 25, but not all cycles have followed the expected pattern. There have been anomalous periods, such as the Maunder minimum, 1645 to 1715, when there were almost no sunspots and the global climate cooled. The Dalton minimum, 1790 to 1830, also coincided with cooler temperatures and extreme weather events. Solar cycle 24, 2008 to 2019, was notably weak, surprising scientists due to its low activity. Initially, it was predicted that solar cycle 25 would be even weaker than the previous cycle. But we were wrong. Solar cycle 25 has exceeded all expectations. In August 2024, it reached sunspot numbers not seen in more than 20 years. The current solar cycle brought a surprise. Its peak arrived earlier than expected. Initially predicted for July 2025, it was brought forward to occur between January and October 2024, with a higher estimated number of sunspots. In October 2023, NASA confirmed that the solar maximum period had begun. However, the exact peak will only be determined after a detailed analysis of the activity. It is expected that the Sun will remain in this maximum state for about another year before it begins to decline. This period may bring intense geomagnetic storms, and spectacular auroras. Major solar storms have already caused significant impacts on Earth. The Carrington Event of 1859 was the most intense ever recorded, affecting telegraph systems and producing auroras in the Caribbean. In August 1972, a powerful solar storm hit Earth between the Apollo 15 and Apollo 17 missions to the Moon. This solar event was so intense that, if astronauts had been in space at the time, they would have received lethal doses of radiation. More recently, in early 2022, a solar eruption was powerful enough to trigger geomagnetic storms, resulting in the loss of 40 newly launched Starlink satellites. With the growing dependence on satellites and technology, protecting infrastructure against these events is becoming increasingly essential. High solar activity can impact space missions, such as NASA's missions to the Moon. The risk of highly energetic solar particles, electronic damage, and communication disruptions requires launches to avoid solar storms. However, there is an unexpected benefit. During periods of intense solar activity, the Sun's magnetic field helps protect Earth and its satellites from harmful long-term cosmic rays. In addition, this period offers the opportunity to witness spectacular auroras. When a coronal mass ejection reaches Earth's magnetic field, an interaction occurs that can result in both daytime and nighttime auroras. The more common green auroras appear when solar particles collide with oxygen at altitudes between 100 and 300 kilometers. The rarer red auroras, like those seen in May, occur when these collisions happen above 300 kilometers, making them 10 times more visible to the naked eye. As the sun reaches its peak activity, we witness not only spectacular events in the sky, such as vibrant auroras, but also real impacts on technology, communication, and even space missions. This intense phase of the solar cycle reminds us how our planet is connected to the cosmos and how invisible forces shape our daily lives. While scientists monitor every detail of solar activity, it is up to us to appreciate the grandeur of the universe and the wonders it provides. Thank you very much for watching until the end. Don't forget to leave your like and subscribe to the channel. See you next time.